In our next discussion, we're going to be solving trig equations, linear in sine and cosine. Now, these are probably the most complicated problems. Well, I wouldn't say complicated. I think a more appropriate term would be the most missed problems on the exam side. So from a student's point of view, I guess that would be complicated. But there's a trick in it. And so it's linear in form, which basically means you have a sine in the function equation and you have a cosine in the equation, and you're trying to solve it. So let's look at an example here. So solve the equation sine of theta plus cosine of theta equals 1, and theta has to be between 0 and 2 pi. Now, here's one of these problems that you can't directly relate sine to cosine, and you cannot directly cosine to sine. Now, sure, sine squared plus cosine squared equals 1, but that's not what I have here. I have sine of theta plus cosine of theta equals 1. I mean, I've had this problem before, and I've given students, and they tell me it's true for all angles because they think it's an identity. And it's not an identity because sine squared of theta plus cosine squared of theta equals 1. That does not mean this. So we need to solve this equation. Now, what we're going to do is a little trick, and that's the problem, is knowing to do the trick. So what I'm going to do is I'm going to square both sides of the equation. Now, of course, if you square the right side, that's 1 still. But when you square the left side, you have to FOIL out sine of theta plus cosine of theta times itself. So that's exactly what we're going to do here. See, so we're going to sine of theta plus cosine of theta, quantity squared, equals technically 1 squared, which is still 1. So now you're like, well, how's that going to help? Seems like it would make it more complicated. Well, look what happens when I square this out. It becomes sine squared of theta plus 2 times the sine of theta times the cosine of theta plus cosine squared of theta. So when you FOIL, that's what the left side becomes, equals 1. Now, remember that sine squared of theta plus cosine squared of theta that we mentioned a second ago? It's in there. It's a sine squared at the very first term, and there's a cosine squared in the very last term. So we can replace those two terms with just the number 1. So we'd have 2 sine theta times cosine of theta equals 0. Where did 1 go? Well, I subtracted the 1 to the other side, and 1 take away 1 is 0. So the only thing left is the middle part of it, 2 sine of theta times the cosine of theta equals 0. And the good news is this is already factored for me. 2 times the sine of theta times cosine of theta equals 0. Of course, 2 is never 0, but sine of theta could equal 0, and cosine of theta could be equal to 0. And now we just have to figure out between 0 to 2 pi when they're equal to 0. Now, I like looking at the graph now. So now that we know what the graphs look like, sine of theta between 0 to 2 pi is 0 at 0 and pi. And cosine of theta equals 0 at pi over 2 and 3 pi over 2. So those are your 4 possible answers. So the apparent solutions are 0 and pi. That's for your sine of theta, because that's when sine of theta equals 0. And pi over 2 and 3 pi over 2, and that's when cosine equals 0. Now, the word is apparent. That means that must be something is up with that, and it is. Now, in order to make this solvable, I squared both sides. The problem with that is that when you square both sides, it sometimes tack on extraneous solutions. Let me give you an example. If you have 3 and it equals 3, okay, and you square both sides, both sides are 9, and that's good. But when you have negative 3 and positive 3, now we know those are not equal. Negative 3 and positive 3 are not equal. But when you square both sides of that, negative 3 squared is 9, and also 3 is squared is 9. So you can get two numbers that are not equal and square them, and they become equal. So that's why when you square both sides, some of those answers may not actually be equal. One could be a plus and one could be a minus the same number. So by putting those 4 numbers, the left side could be a negative 1, whereas the right side could be a positive 1. But when you squared them, they were both 1. So you can't tell that just by observation. But it was a necessary step in order to make it work. Now you're like, well, what do you do then? If some of those numbers don't work, what do you do? Well, here's the thing, is those four numbers, if there are solutions to be had, it's one of those four, possibly more or possibly all. So what you have to do is check them. Check each and every one of them, and if it works, it's a solution. If it doesn't work, it's what we call extraneous, which means it appears to work for the apparent solution. It's an apparent solution, but it doesn't actually work for the problem. So let's look at that. So what we're doing is we're checking each one of them. We put 0 in. Sine of 0 plus cosine of 0 is 0 plus 1 equals 1, and that's a solution. It checks out. If you put sine of pi plus cosine of pi, sine of pi is 0, cosine of pi is negative 1, and 0 plus negative 1 is negative 1, and that does not equal 1. So it's not a solution. Now put pi over 2 in. Sine of pi over 2 plus cosine of pi over 2 is sine of pi over 2 is 1, cosine of pi over 2 is 0, and 1 plus 0 is 1, so that is the solution. So now 3 pi over 2, it doesn't appear going to work. So the values theta equals pi and theta equals 3 pi over 2 are extraneous, so we throw those away. And the solution set is 0 and pi over 2. Because that's what it... Now, the most, how is this problem missed on exams most of the time? Well, people will figure out that they have to square both sides to get that to work. If they get to that point, we still have a problem because they will just give me all four solutions because it seems to work. They forget to check the situation. So there's two biggies on this problem. This is probably one of the hardest types of trig equations to solve because you got to square both sides, which is not typically normal thing to do. So, but you have to square it in order to make the trig functions go down to 1, like the sine squared plus the cosine squared equals 1. And it's what we call in the math world a math trick. It's a trick, and it makes it solvable. So, but the problem with it is when you're squaring both sides, it sometimes adds extraneous solutions. And whenever an extraneous solution is a possibility, you have to check. And in this case, we checked, and there was 2 of them that had to be eliminated for my solution. Okay? So let's look at this summary of the sum and difference formulas for all 6 of them. So the addition formulas are on top, and the subtraction formulas are on bottom for the main 3 trig functions. And again, this is one of those tables that you want to, slides you want to check and look at it, write it down. So in other words, pause this discussion here and write them down and memorize them. You're like, I thought you said it wasn't, we didn't need to know them. This one is provided on the exams, yes. But I'm going to tell you, when you know these without too much looking at it, it makes it a whole lot easier. So, because if you don't look at it and kind of get an idea of what they are, then it makes it much more, it's like you revisit it every time as new, something new. So when I say memorize in this situation, I would say become familiar with them. Becoming familiar with them, meaning when you look on the test, say, oh, I need the addition formula. You know where to go look for it, and you know just by observation. And the reason I let you have them on the exam is because sometimes when students memorize them, they miss it by a sign. It should be a plus, and then they put the minus. In other words, they get the first one and the fourth one backwards, or they'll get the second one and the fifth one backwards as far as the signs are concerned. And I don't want you to miss it for that reason, okay? But I do want you to know somewhat what the cosine of alpha plus beta looks like. So I want you to know it's either the first one or the fourth one. And then I give you the formulas so you can tell for sure which one it is. So be familiar, but not necessarily memorize, okay? All right, so that concludes this discussion. If you have any questions, you let me know, and you have a good day.